Great. What I'm going to be talking about today is something that I've come up with along with some colleagues at my company, Active Solution, about looking at the AI technologies that we've got available, particularly the ones that what we've got available in Microsoft, and kind of breaking them down into kind of five different categories or levels, really depending on how much experience you've got in AI and the challenges of the problems that we're going to be solving. So a bit about myself. I describe myself as a developer, trainer, mentor, and evangelist. I do training courses together with Cornerstone, also together with your Azure Coach, and with Pluralsight. I record training courses and also do custom training courses and seminars and stuff. I love building stuff, so I've kind of not gone into architecture or project management. I just like working in Visual Studio and creating stuff. Much of that work's been in Python fairly recently, and I'll explain a bit more about that later on. I also work as a mentor in projects. So in those projects, I don't write code, I don't build stuff. I just basically help the team to be able to get skilled up in using Microsoft Azure or using the AI technologies. Bit of an evangelist. I like to talk about new technologies and encourage people to use technologies. So my kind of main thing at my company is encouraging people to use Python, starting to look at AI. I work for Active Solution. We build solutions. They're mostly cloud-based solutions for various companies. We're about 40 consultants, and we kind of specialize in working with taking stuff where an out-of-the-box solution won't work, and we basically building Azure solutions in that. As Magnus mentioned, I'm an Azure MVP. I've been an MVP since 2005 when I was nominated as a BizTalk MVP. And now I'm focused more on the clouds technologies. Also do a lot of work with the communities as well as a cloud-based conference. We've got the AI-based conference, and I YouTube quite a lot at Cloudcasts. Alan Smith is my YouTube channel. So machine learning, just to give you a background, traditional development, if somebody said to you, okay, can you build a system that predicts how much an apartment price is going to be based on various bits of import data? Well, the most important thing, as most of us live in Stockholm, is how big is the apartment? And you have a square meters. Then it's going to be so much per square meter in this particular region. So you could actually write some rules in a regular programming language to say, well, take these square meters, multiply it by this, look at where it is, maybe figure out things like the region, whether there's a lift, how old the building is, what the monthly hire rate charge, and you could actually give the answer using traditional programming. Within machine learning, we take a very different approach. We say, okay, let's find as much data as we can about the previous sales of apartments. And let's use that data to train an algorithm that can then actually predict the actual rules that are going to govern this. So the algorithm will know, what the square meter per price is in a certain area. We don't need to tell it that because it has the data and because it has the answers from other apartments. And that's the main concept of machine learning. So we've all been working with, cloud computing. Many of us have been working with cloud computing. In the early days, I remember seeing this diagram talking about on-premise versus infrastructure as a service versus platform as a service versus system as a service. And it's really talking about the responsibility that we take when we're developing a system if we're using one of these technologies. Many of the Azure services are platform as a service technologies. The Azure Service Bus or Azure Functions. I build my functions application. I work with it with data, access to various data sources, but I don't really care too much about the middleware or the functions runtime or the operating system. I mean, you can choose Windows or Linux, but all of this is handled by Microsoft Azure. If we jump down to a virtual machine, we care about the runtime, the middleware, and the operating system. We're responsible as an admin for that operating system. So what I've thought about is within machine learning, what responsibility are we going to take for the different sections within a project? So if you're working with algorithms, you're going to be writing your own algorithm, dealing with how that API is hosted, designing a model, selecting a model. You're going to be responsible for the data set and then calling the APIs. You can also use a framework. So if there's something like scikit-learn or PyTorch or Keras and TensorFlow, they basically provide all of the algorithms for training neural networks. However, you've still got a lot of responsibility for designing the model, selecting the model, and various things like that. You can move on to using pre-existing models. You don't need to design the model. The models are already there. You maybe take some responsibility in selecting which model to use for which particular purpose. You are responsible for the data set and you are responsible for making calls to the API. You can also go to something like cognitive services, and there Microsoft is just providing you with an API that you can call to be able to perform, something like face recognition or entity detection, image classification, various things like that, generating captions on images, and working with text, doing translations. There, all we need to do is to call an API, and we get artificial intelligence in our systems. And then at the applications level, you can actually go into the portal and you can start working with these technologies without writing a single line of code. So I'm going to go down those levels, starting out with applications. We're going to be looking at the video indexer, Azure Video Indexer. Then in the services section, we'll take a look at some of the cognitive services that we've got available. We'll then jump into models. We'll look at working with custom vision and Azure machine learning. And then frameworks. I'll look at some scenarios where building your own model, working with models and using PyTorch or using Keras is going to be a good option. And then actually working with algorithms if you want to start doing the advanced stuff. As you progress down, you do need more knowledge. So when you get to the frameworks level, you pretty much need to be programming in Python, unless you want to look at using ML.NET. But most people at that level are programming in Python, and then all the crazy maths comes in down around the algorithms level. So for applications, we've got the Azure Video Indexer. I'm not going to say too much about it. You can basically get some good idea of what this does by looking at an actual demo of that. So if I go into the Azure Video Indexer portal, this is some of the stuff that I have created here. So, for example, I put one of my YouTube videos into this. It's identifying me as a person. It's basically trained to recognize Alan Smith in there. It's also talking about the actual topics. So it's detecting that this is about Python libraries. It's about software installation. And we can actually go into the timeline and we can see the actual transcript. And this has just been taken from the audio. So this allows us to be able to drop on captions. And then we can also do translations. So if I want to translate this into Swedish, should be able to do the actual translation. And now we've actually got the subtitles coming up in Swedish. It does do celebrity detection. I think Microsoft classifies Microsoft execs as celebrities. So Scott Guthrie is a celebrity here. He's detected within this video. The other presenter, I can't remember his name, is not a celebrity according to Microsoft, or it hasn't actually detected him. But as well as that, you can also train it on other people. So I trained it on my kids. I uploaded one video of James, one video of Jennifer, and now if I upload another video, it will be able to detect where Jennifer is in that video. It will also be able to detect where James is in that video there. So it's pretty good at being able to kind of understand this face detection. If that scares you, don't worry, it's fairly easy to evade. This video here did not detect James. So basic face painting, some kind of a Batman mask, and that will make you invisible to any face detection software. So I'm going to progress down and start to look at the next section. And this is going to be the cognitive services that we've got. So Microsoft produces a range of these services that we can leverage in applications through an API call. So basically, all of these will have usually a free tier and also a standard tier. And the free tier is quite generous. It limits you to something like 20 calls a minute and several thousand calls a month that you can make. So in a really small application, definitely for proof of concepts and experimenting, you can just use the free tiers of this technology. So just to give you a run through with speech, you've got speech to text, text to speech, speech translation, speaker recognition, so it can detect different speakers. I haven't got time to run this demo, but I had a nice one where I could say something in English and it would translate it in almost real time into a different language and actually use the voice. It does the speech to text, and then it does the translation with a text, and then it does text to speech on the translated text. So it can actually do the voice translation between different languages. We've got language, and that can recognize entities like brand marks. It can recognize countries and regions, various things like that. It will recognize cities. It can detect sentiment and analyze sentiment, and also do translation and things like that. It supports a wide range of languages. And then we've got the vision, being able to use the face API, custom vision, and computer vision. And we saw when I was using the video indexer, just uploading a video in that portal and generating all of the transcripts. It's actually using the actual speech to text and the translator. So the video indexer is built on top of these cognitive services. You've got things like the content moderator to detect potentially offensive or unwanted contacts. I have a demo of that on my YouTube channel, which I'm not going to show today, but I will mention about that. There's a video if you want to check that out. Anomaly detection for detecting, machinery. Is there any issues with this machinery based on telemetry data? And also a web personalizer, so you can actually personalize website content for each user. And then what's pretty exciting is the OpenAI stuff. You've probably seen DALL-E 2 and the text generation algorithms. Microsoft is starting to incorporate those, and these are in preview, but you can play around with DALL-E 2. We had a conference at the weekend, and one group of people was generating marketing images using DALL-E 2, and they were hilarious. It's definitely worth looking at those technologies. So a couple of demos I'm not going to show on cognitive services. When I found out about celebrity detection, I was very, very skeptical. And I thought, well, the most famous celebrity in the world is maybe Elvis Presley. And Elvis is probably the most interpreted or most impersonated celebrity in the world. So what I did was I did a Google search for Elvis impersonators, got about 200 photos of Elvis impersonators and put them in with the celebrity detection. It was not able to fool it. Some of the real Elvis Presley photos is actually sneaked in. It was able to identify real Elvis Presleys. If you Photoshop Donald Trump's head onto Elvis Presley, it actually detects that it's Donald Trump. And it did actually detect that some of them were well-known Elvis impersonators, and actually where it was able to pick out those. So I was quite impressed with those capabilities. And then on the content moderator. I thought the best way to stress test the content moderator is through Pulp Fiction. So I found a video on YouTube. It's something called Pulp Fiction F-bombs. It was about 15 minutes long, and it was just every profanity that was mentioned in the film of Pulp Fiction. So what I did was I got the transcribed text from YouTube and then used the actual text and fed that through the content moderator, and that gave me all of the offensive words. I then calculated the timings of the offensive words and stuck beeps into the actual audio. It is good enough to put onto YouTube. It did not get censored. However, it's not good enough to play for you now, but it is available on my YouTube channel if you do want to go and check that one out. Okay, so I'm going to demo Cog services, and I'm going to be using a Logic app to actually show how this works. So this is fairly easy to understand. It's visual rather than code-based. When an HTTP request is received, I'm going to be posting a photo to this Logic app. We're going to analyze the image using the computer vision service, and then we're going to recognize domain-specific content. When we're recognizing domain-specific content, we've got two models. We can use the celebrities model, or we can use the landmarks model. There may be more models coming out in the future, but that's just going to identify celebrities in this image. So the great thing about this is it is an API call. And Logic apps, all these activities are doing is really just making a call to the API. And I have a postman here with a tab that's going to basically run that Logic app. Okay, so I'll just show you the actual photo that I was using. This was, if I open this one, that's the image that I'm sending in. We've got a celebrity and we've got a car. And the response that is coming back, if I just send that image there, is first of all, it's coming out with the categories. So it's others, outdoor, and then we've got the tags: outdoor, person, sky, grass, car, tree, road, man, vehicle, standing wheel, and so on. And these can be used if you want to build a search engine where you type in car and it finds all of the actual photos that contain the car. Then we've got the caption. It's saying Jeremy Clarkson standing in front of a car posing for the camera, which does seem to be very accurate. And then in the celebrity detection, the text, this is in the actual image analysis, it came out with Jeremy Clarkson, but this celebrities bit will identify actual celebrities. So it's 99.9998% certain that this is Jeremy Clarkson, and it's got the actual face rectangle, so you could actually identify his face there. So Cog services are really, really good if you want to just use a trained model. You don't know too much about AI. You haven't got a really big data set of images to actually train these models on. You just want to use something that Microsoft has provided. make a call out to that and be able to include AI in your application. As I mentioned, it's an API call. You don't have. I did it in a Logic app because it's just a nice visual way of showing it. But basically, if you can write code to consume an API, you can use these services. And as I mentioned, there is a free tier available on all of these services. So what I may want to do, instead of just identifying that this is Jeremy Clarkson standing in front of a car, I may be interested in what type of car Jeremy Clarkson is standing in front of. So if I open this thing again, what we may want to do is to classify this and say, okay, what type of car is that? This is a scenario where Microsoft, the cognitive services, doesn't yet actually have a car model, can't detect celebrities, landmarks, and types of car. So this is something where we've got to actually go down a level and start to actually train our own models. So if we go down into the model section, there's two technologies that I'm going to talk about here. There's the Azure Custom Vision Service and Azure Machine Learning. I usually confuse custom vision with computer vision. They've got these kind of two services. The computer vision is the one where Microsoft has already trained the model. The custom vision is when we are going to be training our own model based on our own data. Now, officially, the custom vision fits into the cognitive services section. So it is part of cognitive services, but I classify it being in the models section because we are going to be training our own model. We are going to be taking responsible for the training data and the analysis of those models. So the Azure Custom Vision allows us to do object detection and image classification. This is an example of object detection where we've got fruit, and what I've got to do is in the images, I've got to draw a bounding box around these fruit and say, this is an apple, this is an orange. You do this for about 50 photos, and you'll get a fairly basic model that is able to actually process these. I think that was done with about 20 images. Oh, no, you can see there's a 21 bananas, or maybe you can't see 21 bananas, 29 oranges, 32 apples. That's a really, really small data set. And it's coming out with this mean average precision of 85.1%, which is quite accurate with a very small data set. And this is the actual results from this. It's pretty impossible to read, but it's saying that it's 88.7% certain that that is an apple. It's able to recognise those fruit. This is really easy to use. My daughter was attending a Coder Dojo a few years ago, and I did a hands-on lab where the kids were analysing images and doing face detection with Harry, Ron, and Hermione from Harry Potter photos. So I wrote this actual detailed lab and wrote a Word document on, stage one, do this, do that. And the kids just threw it to the side, ignored it completely, and went in and just managed to solve the problem without reading the instructions. So it is very easy to use, very basic. It provides a pretty sophisticated functionality. So definitely recommend checking that out if you want a quick intro to AI. So I'm just going to do a quick demo of the custom vision service because I have a model that I have trained. If I go into the custom vision projects, these are some of the models that I have been working with. I've typically been taking data sets from Kaggle. So if you want to get some data sets for training, they have this thing with about 300 or 400 different species of birds. So you can train on identifying specific birds. You've got like a cats and dogs data set. And the one that I was working with was these fast cars. So what I've got, Top Gear never actually tests cars that anybody can afford. They're always like Lamborghinis or GT3s or Enzo Ferraris and stuff. So I've done the classification for those types of cars, 100 image of each tag. Now I've trained this and I've published this as a model. So when we publish it, it becomes available with this prediction URL that we can call with an API key. So again, you can just send an image and you can call an API. So what I should hopefully be able to do is to modify this logic app to actually identify the car type. So if I add an action, I'm going to search for custom vision. And we've got this classify an image that I can specify in. And I've got to specify, like 3 different parameters, the image content, the publish name, and the project ID. So going back to the portal, I think if I go into the settings, is it? It will tell me my project ID, which should be somewhere. Here it is. So I can drop in the ID of the project. The publish name is going to be in the endpoint prediction URL. This is Like I said, they're published as fast cars. And then the image content that I was going to use, which is going to be the image that we have posted. So this will be when an HTTP request is received, it's going to be the body that we're going to be sending in. So did I select that? Yeah, that should be fine. And then what I want to do is just modify the response because here we are returning the analysis and the domain-specific content. We also want to return, I'll put it at the top actually. And what we're going to want to drop in is what's coming back from classify an image. It's going to be the predictions, I think. And we're going to need a comma there if it's going to be a JSON. So save that. Why did that fail? Oh yeah, I missed a quote. Thanks. Okay, so that should be fine. And just see what it thinks of that. Yeah, it's not coming out in the correct order, but here we've got the prediction that it was 96% certain that it was a Tesla Model S, which was the correct car. Let's try it with another one. When you do demos, you always pick the photo that is going to work. So we'll try one that I haven't tested before. I'll just show you what that photo was there. It's a bit small to see. Yeah, yeah, it is. And there's quite a few celebrities there. Okay, so the people, it's got Richard Hammond, it's got Elon Musk, it's got Jeremy Clarkson. No, I didn't get James May. Sometimes it doesn't detect James May, sometimes it does. Elon Musk, Richard Hammond, Jeremy Clarkson posing for a picture. Yeah, and it got Model S as well, 88% certain there. So Microsoft has a lot of budget and a lot of time to be able to train these models. And what they're doing here is they're actually using a pre-trained. Sorry for the detecting the celebrities. They're using models that Microsoft has trained. Also, they're using these object detection algorithms, the latest algorithms to be able to train those models. You can do a quick train in about 3 or 4 minutes. So, for example, if I want to train it for a different bird type, I should be able to go back to the birds. So if I go back to custom vision, we've got this one with birds, and I've got sort of various different types of birds types here. I think I should be able to add images from another one. I'm using 100 images from each one. So if I go into the images, we should have birds, and into the training section, let's take black swan. Awesome. So if I take that up to 100, I think. And we can load those images. And that was uploaded successfully. And then just click on train. And you've got the option of doing quick training, which takes a few minutes. The advanced training, you can actually set a budget there for a certain number of hours, starting with a minimum of 1 hour. My recommendation is if you want to just do a quick proof of concept on this, doing the quick training will generate a very, very quick model. So it'll tell you in a few minutes, if you are actually going to get any sense out of the data. And if it's worth pursuing, and then you can invest a bit more time in doing more advanced training. So that will hopefully be done by the time we finish the session. So going into working with models in Azure ML, this is almost going down another half level because it's good if we understand a bit about Python. Also, if we understand how to work with data and data cleaning and being able to do things like that. And also the SDK for Azure ML is Python based. So you do really need to know a bit about Python if we're going to be starting to work with these particular technologies. But what Azure Machine Learning will provide is basically a portal that we can use for working with team-based machine learning development. When I first started out with working with machine learning, I was programming in Python. You were playing around with these notebooks. You were kind of just writing code and scripts and running console applications on your local machine. There wasn't really a centralized way where everybody can work together. Everybody can use different data sets. So for experimenting, it's fine to play around with Python on your laptop or on your home PC and just play around with those algorithms and data sets. But for team development, it's really nice to have the data sets, the jobs, all of the compute environments all centralized, so the team can basically work with developing these various algorithms. So the basic workflow, we're going to get some raw data. The data is probably not going to be in the correct format that we would like. We would like to do something to the data before we can use it. So really, data scientist, people joke that the job really means data janitor. You're doing a lot of cleaning and fixing of data because it's probably not going to be in the optimal format to send it into a model. Once it's been cleaned, you then split the data. You can either split it into 2 sections or 3 sections. And the idea is that when you're training the model is going to have maybe 80% of the data. And that model is going to be trained on that certain section of the data. What you're going to do then with the other half of the data that the model has not seen is you're actually going to do the scoring of the model. There's something in machine learning called overfitting. And overfitting means that instead of actually being able to calculate and figure out the price of an apartment, the model just remembers that a certain apartment with certain parameters will cost a certain value. It can get very, very accurate at being able to predict on the data. But if you give it something that it's never seen before, then it can come out with a strange prediction. So what we want to do is when we score the model and evaluate the model, we want to give it data that it has not seen and see how accurate are the results with the data that has not been seen by the model. We can then evaluate the model and decide if we're going to use that particular model. So, apartment price prediction. If you don't know too much about the models and machine learning in general, you can actually use something called Auto ML, which will basically provide an automated way of being able to run many different models on the same data and analyze the accuracy. So if I drop back to the portal, I'm going to go to the machine learning workspace, and I've got a number of data sets in here. If we go to the actual data section, and one of them should be the apartment price data, which I have uploaded. So what I did, I was very inspired by Tess Ferendes, who basically did a presentation on working with AI for developers. And one of the scenarios she picked was house prices in her region. She was, looking at buying a house at the time, so was really interested in house prices. So I basically got these. These are apartment prices fairly near where I live. So we've got the address. To anonymize it a bit, I took off the actual street numbers and just put the name of the road. We've got the actual price the apartment was sold for, the monthly fee, and the actual region, area, and the number of rooms. One of the things here that I have not done is I have not cleaned up the region because different estate agents use different names. So here it says Brummer Traniberi and here it says Traniberia. These are the same region, but as far as the model is concerned, they will be counted as different regions. So you probably want to do the substitution for all of these different regions and be able to kind of just narrow it down to Miniberia, Traniberia, and be able to specify that. The other data seems fine. That should really be understood. So it's really just that region. And then we've got the date when the apartment was sold, which is also fairly important. So what I can do is I can go into automated ML. I can create a new automated machine learning job. The data set that I'm going to be using is going to be the apartment price data. I can click on next. And then I can specify the job. I think I've got an existing experiment, which is the apartment price prediction. If we run another run on that. This is the target column, and this is saying, okay, out of that data, what is it that we are trying to predict? So I could select that it's actually the price that we are trying to predict, and then I can specify the actual compute cluster that I'm going to run on. I'm running on CPU cluster low. I can click next, and it's asking us what type of machine learning algorithm we want to work with. It's predicting time series forecasting, which is basically based on the actual sale data. I'm actually going to go for regression as the actual one, which is, well, we're coming out with a numerical value for the actual prediction. Then I can click on next. I don't need to do anything more there. And that's it. This will basically create an AutoML job. It will start to execute that job, and it will run through all of the actual predictions of the different models. It will analyze all of those models. It will give us the best of the best model. So it's going to take a while to run, maybe about, I think it's about 18 or 30 minutes it takes to run. So I should be able to go into the jobs, look at all the experiments and see the apartment price data when I've run that previously. So this was one that has completed. Oh, it took 1 hour, 3 minutes and 59 seconds. And we can go in and just look at the actual predictions for this. So these are all the models that it has come out with, and all of the statistics on those various models. And you can see that voting ensemble has come up as the most accurate one. Now, what an ensemble is it basically means that it's using several different models, and then they can basically vote on what the apartment price is. And they will have different weights within the actual vote. I don't know if it actually shows the actual types of models. Yeah, view ensemble details. That should show it. So what it's doing is it's coming out with this standard scalar wrapper, and then this max abs scalar elastic net, and you can see it's using 6 or 7 different models, and each one of those will have an actual weighting score of how much percent they give towards the apartment price. This is something that would take several days to do as an actual data scientist. You've got to look at the problem, understand which models we should use in the problem, test all of those models, evaluate all of those models, and then figure out the actual weighting that you're going to use. So that's really taking a lot of work away from. It's taking a lot of work away from you with getting something that you can develop fairly quickly. Once the model is trained, you can actually deploy this to a real-time endpoint, which will create a Docker container which hosts this particular service within Microsoft Azure. If we go into the endpoint section, I've done one of these already, which is this apartment price prediction. So if we just go on test, we should be able to send in some test values. We've got the date, the address. So I think I've got the data here. I'm just going to copy paste one of the actual apartment streets in here. So if I take Svartvikslingen and drop that in as the address, and we go to the region, Bromma Miniberg. Drop that in. The monthly fee will be 4,500. The area will be 65, and this can be a 3-room apartment. And test that. It's coming out with 2.71 million, which seems very low, but that was the price in 2000. So if I change this to 2022, and we'll put today's date, we can go for 10 and then 27. Coming out with 4.5 million as the actual price prediction there. So very easy to run, very easy to test. They even give you, if you want to consume this from Python or C# or R, it gives you the actual code that you can go in and make that API call. It's providing a lot of good functionality there. We've also got within the Auto ML the option now to work with object detection and classification, and also segmentation of images. It's kind of very many scenarios where Microsoft builds 2 technologies that does the same thing. So we've got the custom vision, where we've got this easy portal where we can load up images, and we've got the Auto ML, where we can work with doing things like object detection, image classification. But it's much more complex to work with. There are some advantages of using Auto ML. You can use much more images. Also, when you're working with the custom vision, you get billed per call on your API. So if you want to analyze videos, it's going to start to get expensive. I think I worked out it's going to cost several thousand krona to actually analyze an hour's video in using it, because you're paying for every API call if you're doing like 50 frames a second. With AutoML, you're hosting this in a Docker container. So instead of paying fractions of a krona per call, you're paying krona per hour for that container to be hosted. So do the maths and think about, is it worth actually hosting this, having this thing running 24/7? But then I can make lots of calls against that, and I'm not going to be billed on a per call basis. You can also download the models and you can run them on premise. If you would like to run them on your local machine, you've got the option to be able to do that. So if I drop back to the portal, I can go into the experiments. We can find the jobs. And I basically did this Lego face detection job here. And this is showing the accuracy of the model, how accurate it was getting with these precision and recall values. So you can see when it actually finished here, it was getting quite accurate, and then it stopped the training. It took 15 minutes, 43 seconds to train this, and I was running on a Tesla K80 GPU. Um, so looking at the actual compute cluster that this thing is running on, I actually use the low priority compute clusters. So this is going to cost 23 cents per hour to actually run this. If I'm creating a new compute cluster, we've got the option of using CPU or GPU. For images, we typically need a GPU, and this thing is costing $1.17 an hour. It's pretty hard to read if you're near the back. $1.17 an hour. If we go into low priority, it drops to 23 cents an hour. We can also use a Tesla V100, which is basically I'll just Google in the image search actually. One of those guys. So 15,000 krona or 26,000 krona. That's going to cost if you want to bang that in your machine. That GPU, you can't play games on it. It has no monitor connection. It's just built for doing the actual processing. It's actually cheaper to run on the more expensive model, more expensive GPU, because it will run much quicker than on the regular GPU. And these machines are basically provisioned and deprovisioned when we need them. So low priority is really the way to go. This will mean that you get the machine instance when it is available within the data center, and getting that cost saving is really going to motivate that. I've very rarely had a problem of not getting my machine provisioned when I would like it to be provisioned. But normally if you're running a job that's going to take several hours, you finish work, run the job, it will have run at some point during the evening. Come back the next morning, and your model will be trained. Okay. So if I run a quick demo of this, I think it's this one here. What I'm doing is making calls to the API that I've published for the Lego minifig face detection. I was going to do something with face recognition, but using people. People get a bit scared about that with the privacy issues. So I decided to use these Lego minifigs. This is kind of okay at being able to do these predictions. You can see that this one was pretty good. It got all of those. That one was very good. That one was good. That was good. But then this one didn't really work too well. That one was a bit miss, and that one there didn't really pick up too much on that. So the labeling on this, I can just show you that quickly. If you go into labeling projects, I think I need to close that. What I did was I uploaded a bunch of these images, about 104 images. I've only actually drawn the bounding boxes on 53 out of those 104 assets here. But here is where we do the data labeling. This will take a long time. It is quite a tedious process. You've literally got to say, well, I've only got one thing that I'm detecting, which is face. I've got to draw my bounding box on the face and click on submit. And then like that. Microsoft has these various companies that you can outsource this to if you would like to do that. So you don't have to, sit there doing this for days and days and days. There are other services that will be able to do the labeling for you if you've got more complex scenarios. But that's basically how the labeling works there. So on to the actual frameworks. This is where stuff starts to get interesting. If you really don't want to learn Python, there is ML.net, but I'm not really sure about the future of ML.net, how well that's going to be adopted, how well it's going to be supported in the future, because this is really decided by the community. And the community is really talking about Keras and TensorFlow a lot as being these machine learning frameworks. I started out learning TensorFlow, and I've switched on to learning PyTorch. So I've used both of those frameworks. And this is basically some Python code in Keras, where we're basically creating a sequential network. We're specifying the compiler that we're going to be using, defining a loss function, specifying the metrics, and then we're actually training and evaluating the model, and then predicting the model. So not too many lines of code to actually build and train a model there. So scenarios where you may want to do model classification. I'm just thinking I didn't actually turn the sound on the actual machine. I don't know if I'm sharing my sound. So what I'll do is I'll stick my microphone next to the PC. And this is one thing where I was wanting to look at doing music classification, but doing it in real time. So this was a video I got off YouTube with different music genres, and I don't know if we're getting any sound out here. Yeah. So it's quite good at picking up hip hop there, and then we get into rock music. It doesn't actually have rock as a genre, but metal was picked up quite well there. Folk music doesn't have a genre. It's kind of getting a bit confused about what folk music is, predicting it a bit as country music. Then we've got soul music. So that just comes out as disco. And then EDM, it doesn't really have that classification for electronic dance music, but it's predicting that as being pop music. And then we've got blues, which it seems to be quite accurate on as well. So that was training a network to be able to recognize stuff based on the actual spectrograms from music. Companies like Spotify are using that a lot. And then another algorithm that's really nice, talking of Spotify, is this Spotify Annoy. Annoy is actually an acronym, one of the coolest acronyms I've come across. It stands for Approximate Nearest Neighbor. Oh yeah. And the challenge that they have is being able to actually find similar music. So you've got a piece of music that you like, and is there any music that sounds similar to this music? We're not doing the classification, saying this music is EDM, so let's find more music that's EDM. You're also not looking at do other people like this music, because if a new tune comes in from a new artist and it's brand new, nobody's actually clicked like on it yet. So how do we know which people are going to like a new song? So this is able to identify similarities, and what they do is they use the features that are coming out of a neural network. So a neural network that does classification, they've got this classification layer, which is a linear layer. And what happens is we detect edges and then shapes, and then we detect features. And by looking at the different features, we can say, is this a dog or is this a cat? We do our prediction. However, if we remove this bit of the neural network, then we get numerical values for all of the features. Now, depending on the network you're using, you might have 512 or 1024 of these actual number vectors, or maybe more than that. So what you've got to do is you've got to find something that has the close similar numbers. So that's what it's talking about when it's the nearest neighbors. There's a great video on this on YouTube, but it's basically finding the nearest neighbors, but you're in 512 dimensional space because there's 512 of these parameters. So it's quite a complex algorithm that it's using. And what we can do is basically build an index. So we get lots and lots of photos of maybe cats. We basically run those all through the actual neural network that we've modified. We get out the feature vectors, and then we send that into Annoy, which is going to basically build the index. And what we can do then is we can save out the index file. And then to actually say you've got this cat, we want to find cats that are similar to this cat, we basically load up the index file into Annoy, run that image through the neural network, we get out our features, and then that's going to give us some results here with cats that look like that particular cat there. So the actual features in a neural network, this is a really trippy video. It's something called Deep Dream, which researchers had done. And what it was doing was looking into the neural network and identifying the types of features that the neural network is predicting. The journey starts out when it's doing things like edge detection. So you can see there it's just detecting edges, it's detecting really, really basic shapes. And as we get deeper into the layers in the network, it starts coming out with all of these actual features. So this is kind of how the neural network sees the world and is able to identify these. So these are kind of the things that we're doing the comparison on within the actual model. Okay, so I think I've got a demo of that. I'd actually trained this on dogs. So I think this should be able to identify similar dogs. Okay, so this image here is the actual image that I've sent in, and it's saying find dogs in the dogs data set that are similar to that one. The first one that's coming back with is the same image. That kind of makes sense. But you can see that all of these dogs do kind of look like the first dog that we've got there. It's able to do a pretty good job of being able to identify dogs that are fairly similar. Also, the actual pose of the dog. You can see that these are the same breed of dog, pretty much in the same type of pose. As we go through, we've got other dogs there. Again, you could do this with face recognition and identify similar faces. Maybe it's a bit intrusive to do something like that. So here we're doing this with the actual dog detection. And I was thinking of doing that with the Lego minifigs. There's thousands and thousands of these different faces. It would be nice to be able to hold up a minifig face and be able to recognise which actual Lego minifigure it was. That's a nice example of doing that face detection. I'm currently working on that thing now. So the thing that impressed me about using that is the actual simplicity of the code. I mean, I was talking about, you've got to take this neural network, you've got to modify the layer, you've got to do this, you've got to identify all of the actual features. The code is not that difficult here. So what we're doing is we are basically using a model, and this is a pre-trained model that is supplied in the PyTorch library. So I'm basically generating the model. It's a new ResNet 18. I'm actually loading up the default weights into the ResNet 18 model. And luckily, the default weights for this model are really good at being able to classify different dog breeds. It doesn't just say this is a dog, it says what type of dog it is. So the model's great at identifying features in dogs. And then we've got to get rid of that fully connected linear layer that does the classification and replace it with a layer that sends out the actual weight values. So that's that line of code there that uses this identity layer. And then we can just call model eval that says that we are running in the evaluation phase. We've got to transform the images because they can be different resolutions. We're going to resize them to 224 by 224. And then we're just going to open up an image. We're going to run that through the network. I just do, we're going to actually transform the image. We run it through the network. So that's the code to run it through the network. We get out the result. And then I'm just calling on the Spotify index, get nearest neighbors by vector, and passing in the actual result and telling it to return 24 values. So it's about 10 lines of code in Python to be able to build that image search, which I'm really impressed about how easy that was to implement. So what we'd like to do is to train that model in Azure ML. So what I can do is show you the code that does that. So we have the actual script called create annoy index. And what this is going to do is it's going to iterate through all of the images in a specific folder. It's then going to run the images through the model and then add them onto the index. And that's basically going to build up the actual index. We then do a build on the index and we save the index. And that's the actual script that's running. So I could run that on my local PC and just create the image locally. However, we've got the option of being able to submit this as a job to Azure Machine Learning. So what I'm doing here is saying, okay, this is my Azure subscription. This is my ML workspace that I'm using. I'm going to create a client on that, and then I'm going to use the minifig data set and basically I pass that. And this is going to run the actual job. I'm saying that the actual code that you need to upload into the actual image is going to be the code in this src folder. The script that we're going to run is basically Python to run that particular script there. And then I specify the input data parameter, which is going to be a pointer to that particular data set. And then we actually submit the job into machine learning, and it will basically run that job. So if I run this, it should actually provision that index creation job into Azure ML. And I think I've got my machine instance running, so hopefully that job should run fairly quickly. On the other hand, the other job may be in the queue in front of it, but we'll see what happens there. So if we go into the Azure ML, we go into the jobs. Here's the actual job that we are running. and it's currently in the queue waiting to be executed. It's running on a custom environment that I have created. So what we've got is the standard virtual machines. If you want to do PyTorch or you want to do TensorFlow, there will be an image that can do that. However, the Spotify Anoi is not installed on those images. So if you understand a bit about Docker, this is basically the description of a Docker container, and it's saying when this container is provisioned, I need to have PyTorch installed, so that's installing Torch. I'm also just telling it to install Spotify Anoi. So I just took a standard image, added that line of code there, and it's using Spotify Anoi to do that. And then the actual cost of running that, this is running on the, if we go back to the job. Yeah, this is running on CPU cluster low. So the actual hourly cost for the virtual machine on that is 1 cent per hour to run that particular job. And it took, I think it only takes about 5 minutes to run that job. So it's going to be less than 1 cent to actually do the processing for that job in US dollars. So it's pretty inexpensive to be able to do that, do this type of stuff. It's not going to rack up a huge budget. Okay, and we're going to move into the actual. Yeah, I've demoed that. We're going to move into the actual algorithms section. One of the things that really impressed me with machine learning was this video here. What they're doing is they're taking a video of somebody dancing, and then they're able to actually extract the detected pose. I don't know if you remember a few years ago, Microsoft came out with this Connect sensor, and there was actually a Connect SDK that you could work with. So you could plug your Connect sensor into your PC, and you could actually detect the skeleton that's coming from the actual. It's got a 3D camera, all of this infrared and lasers and type of stuff, so it can actually detect poses. You can actually do this with an AI model, because what they've done is they've taken video and they've taken the actual poses from a Kinect sensor, and they've been able to say, well, based on this image, predict the particular pose. So there's something called Open Pose, where you can basically send in a video and you will get that detected pose. So you don't need a Kinect to create that. What they're then doing is taking somebody who is just making a few movements, and they're actually mapping one person to another person with the actual dancing. Now, if you want to do this at home, this is or something fairly similar to the PC I'm running at home. It basically caused a bit of a hassle at work when I requested this home PC, because it's got an NVIDIA GeForce RTX 3090 in it, which was really hard to get at the time. I think it took about 2 months to get the PC delivered. This is not for playing games. This is because it's got 24 gigabytes of RAM on the GPU. Now, when you want to train something for like the motion transfer, it's about 12 or 16 gig to actually load the model into the GPU. So if your GPU doesn't have a lot of memory, it just throws an out of memory exception when you try to create the model. You can run it on the CPU, but on the GPU, I think it took 5 days to train one of these models at home, or about 160 hours to train it in Azure ML. That's nothing compared with the generative AI. The models that they're training, like DALI 2, are taking, I think it's 32 days on 1,024 GPUs that it takes to train these models, and costing hundreds of thousands of dollars to actually train them there. But I'd recommend getting something like that with a nice GPU if you do want to do this at home and be able to run the models at home. You can spin up the instances in Azure, but it's a real pain if you're working on, because it's Python, it's not compiled. So you submit a job, it creates the job, you get an error, and then you've got to fix your code, submit the job, test it again. It takes like maybe 3 or 4 minutes to actually run each job. So debugging is a real pain. Even though when you actually want to run the job, it's nice to have it running in an Azure VM. There are disadvantages to this. When I was testing the model for 5 days, this was actually in the summer when I was training this model, and it just sounded like the hairdryer was running upstairs continuously for 5 days, and it was giving out about the same amount of heat as a hairdryer as well. I'm planning to be out of the country when the electricity bill arrives. I'm trying to schedule a conference because it's not going to be too nice. But this kind of shows what this is equivalent to, that $4,000, and you can get days and days on dedicated and low priority instances there if you do want to spin this up. That's not taking into account the electricity. So I'm guessing that that would add quite a lot to it. So yeah, I did promise that there was going to be dancing in this. So yeah, yeah. Why, can you put the music on? Yeah, this was in the Everybody Dance Now. One of the samples they did was Bruno Mars. I say this is a bit like brewing beer. So you basically get your data set, you run this 5 days later, you get a model that looks like this, and then you kind of realise that you could have done a lot better with generating the actual data set, generating something a lot more cleaner. I haven't had the time to be able to run this again and generate a better model, but the ones that they were doing in UC Berkeley, I think they got something similar. They'd done something a lot more cleaner with the actual data. So there was their actual target subjects, and you can see that they've managed to. It's not perfect, but they've got it a lot more cleaner than I did by using a much cleaner data. So I like how it also gets the reflections as well of the actual appropriate positions, which is fun. So this is really running with algorithms in Microsoft Azure. So this is stuff that was done at UC Berkeley. So if you do want to, do a PhD and be able to play around with the latest and greatest algorithms within machine learning, you do have the functionality to be able to do that and run that on the actual, GPUs that you've got available within Microsoft Azure and leverage those low priority VMs to actually bring down the pricing. Another thing that's interesting is the evolutionary AI. I was playing around a lot with the reinforcement learning and looking at how you can build an AI using Python to be able to play StarCraft. So this is like the games of StarCraft that it was playing up to 23 different generations of games, and this is showing the actual score. And I was focusing on something like, build as many minerals as you can, or build a strongest military as you can, and specifying the score on that. And as it experiments with different strategies for playing the game, it's actually able to evolve here. So there are real world solutions to this. Microsoft does have reinforcement learning available in Azure ML, and game companies are starting to use this for the NPCs or non-player characters to be able to develop them with intelligence. Have a driving game where the actual cars are really, following the good patterns for driving and learning how to drive around the tracks by using evolutionary learning. So this basically has a concept of an agent, and the agent is going to work within an environment. The agent can take an action, which is basically doing something within the game, and that will change their state, and they will get a reward if it's a good action or if it's a bad action, if it advances this or not. And this is kind of an example of the multi-agent AI. This is one of the simple demos where these purple spheres have got to move onto a black sphere, and because there's three of them, they've got to react to other instances as well, and be able to avoid other instances and cooperate there. So this is actually the first machine learning project that I ever built, which was evolutionary learning. I'm doing this on premise, but these cars should basically learn to drive around a track, and it's using, you can see the neural network there, and we're starting out with a generation of 50 cars, and they're pretty hopeless. They're just going to crash into a wall, or they're initialized with random numbers, so occasionally you do get one that's okay. That got a long way, 1,049 pixels. And what we do is we take the most successful cars and we take the configurations for the neural network and hand those on to the next generation of cars. So hopefully, after a few generations, it should actually learn to drive around the track. I'm going to leave that going and then just round off because my time is almost up. I will also mention the data science VMs. If you don't have a big box at home, if your boss won't buy you one, then the data science virtual machines are available. So this comes, there is two flavors on this. There's a Windows flavor and there's a Linux flavor. And you can just spin up a virtual machine machine, instead of, when you get a new virtual machine, you've got to install everything. This has everything that you will need installed. So it's got all of the actual frameworks, all of the languages, the development tools. It's got Visual Studio, PyCharm, and the various, code that you need, Jupyter notebooks, and all types of stuff like that, and all of the tools to integrate with the data services. So this will basically give you a desktop in the cloud that you can use for the machine learning experiments if you want to run that. Thanks for listening. My name's Alan Smith, and please feel free to ask any questions at any time during the conference. Does anybody have any questions now? Okay, so we'll break for coffee, and who's on next, Magnus? Jakob. I'll hand over to Jakob. Thanks very much.